Hello dear friends, welcome to my channel. Today's discussions is CSIR NET 2022 question answer. If G is a cyclic group of order 36, then find the number of generator of G. Number of generator of G equals to phi 36 into phi 3 square is equal to 4 into 1 minus 1 by 4 into 9 into 1 minus, sorry, this is 1 by 2, 1 by 3 equals to 4 into 1 by 2 into n into 2 by 3 . So it is 2 into 6 equals to 12. Now friends, we are solving next problem for the matrix 0, 1, 1, minus 1, 2, 1, 0, minus 0, 1, minus 1, 3 and lambda equals to 1 be eigenvalue of A. So 3 is eigenvalue, minus 2 is eigenvalue of A. So friends, we have to find out characteristics equations. So fx, let fx is equal to x cube, and this portion is the trace minus trace of, because 3 cross 3 matrix this is, so trace of eigenvalue, trace of matrix trace of A into x square plus adjugation A II, sum of AII, summation of AII x minus det A to 0. I just find out characteristic equations. So friends, trace of A fx is equal to trace of A 3 plus 2 is equal to 5, so minus x cube minus 5 x square and AI. Summation AII, how can we find out? It is very easy. That at first I find out this portion, 3 into 2, 6 minus 1, so it is first is 7, and when I will get this portion, so I get 7 plus 0, and when I will this portion and this portion, then I get plus 1 into x and minus det A. Get det A, friends. Det A is very simple. Det A is det A is 4. So it is 4 equal. So friends, this is my total characteristic equations I get, and now it can be simple way it can be written x cube minus 5 x square x minus 4 equals to 0. Now we see that eigenvalue 1, so lambda equals to 1, so we just factorize this portion, 1 minus 5 8 minus 4. And now in the case of 1, so just factor is x minus 1. So it is 1 and it is 1, so it is minus 4, and minus 4 into 1 minus 4, after that you get 4, and 4 into 4 minus 4 plus 4, this is 0. So I get these equations. So my equation will become x square minus 4x plus 4 equals to 0. And fx equals to, it can be written x minus 2 whole square into x minus characteristics equations. But characteristic equation is x minus 1 whole square into x minus 2 whole square into x minus 1. So 2 and 1 is my, so first option is wrong, 3 is eigenvalue, minus 2 is eigenvalue, this is also wrong. So A is diagonalizable, this is also wrong. Note that a diagonalizable if all function its minimal polynomial are equal. Minimal polynomial, so I will check that A is diagonalizable or not. So I have to say that minimal polynomial is linear factor. Now I have to check that it is linear factor or not. So minimal polynomial should be x minus 1 and x minus 2 whole square and x minus 1 into x minus 2. So at first I check this portion. So my problem will become a minus I and a minus 2I, and we see that this value will become 1 minus 1 minus 1 0 1 1 minus 1 1 1 2, and this portion is minus 2 minus 1 0 1 0 minus 1 1 1 and 1, and that is does not equals to 0. You see, this is does not equals to 0. So my minimal polynomial should be, this is my minimal polynomial, and is not linear factor. So that A is diagonalizable. This is wrong. Now option C is correct, but how it is correct, I will explain how it is correct. Because friends, when lambda is equal to 1 and 2, am1 is 2, am for 1 is 2, and gm equals to how, gm equals to, first is 1 and second is 1. How can I get value? Because gm of 1 equals to n 3 minus rho into a minus 1 I, and gm of 2 equals to 3 minus rho into a minus 2I. So this is the main problem, and now you will see that rank of a minus 2I is equal to This is also 2. So 3 minus 2, 3 minus 2 equals to 1, and 3 minus 2, this is equals to 1. Now friends, next problem, mod of z equals to 3 by 2 and fz is equal to e to the power I pi z, z minus 1, z minus 2 I whole square, and integration fz 2 pi I c. My circle, unit circle, and you see that z minus 1, z minus 1, z minus 1 means this is the 3 by 2, this is 3 by 2 I, this is 3 by 2, this is minus 3 by 2, and this is minus 3 by 2 I. Now friends, you see that it is z minus 1, so 1 is included. Z equals to 1 and z equals to 2I, both are in pole. You see the pole, z equals to 1 inside the center, inside the center, z equals to 2I outside the, so fz is analytic at z equals to 2I using cauchy residue theorem. Integration c fz dz equals to I sum of residue of fz at inside, at its pole inside. So residue of fz comma 1 is equal to limit z tends to 1 into z minus 1 fz equals to limit z tends to 1 e to the power I pi z 1 by 3 plus 4I, and residue of fz u comma 2I equals to 0. C equals to 1 by 3 plus 25 minus 4 by 25I. So mod of C equals to 1 by 5. So my answer is C equals to 1 by 5. Now friends, we will solve another problem. F such that R tends to R be defined as fx is equal to x square and gx is equal to sin x. Then which of the following uniformly continuous? So whatever I get h x is equal to g f x equals to sin x whole square, and h dash x is equal to 2 cos x is equal to sine 2x. Sine 2x, this is bounded. This is bounded. So f dash x is bounded on R. The fx is, hence fx is uniform convergent. So option A is correct. We'll check option B, option C. Option B, hx is equal to x square into sin x. Option B is x square sin x. Option A is sin x square. Option A. And option D is sin x whole square. So friends, you will check that limit x tends to infinity, fx is equal to infinity, and limit x tends to minus infinity, fx is equal to infinity. So all the options are not correct. Number 5 is A 4 plus 4 matrix. Eigenvalue of A is -1, 1, -2, and B equals to a to the power 4 and 5a square plus 5i. So trace of A plus B. So friends, trace of A plus B means sum of the eigenvalues. So A eigenvalue is -1, 1, -2, and B equals to 1 minus 5 plus 5 equals to 1 first, and second is also when B minus 1, then it is also 1, and second one is this is also 1 minus 5 plus 5, and 1 equals minus 5 plus 5 equals to 1, and -2, for -2, B minus 2 equals to 2 to the power 4 means 16 minus 20 plus 5 equals to 1. So we get the trace of A plus B -1 plus 1 plus 1 minus 2 plus 1 plus 1 plus 1 plus 1. 1 2 3 4. Yeah, okay. 1 2 3 4. 1 2 3 4. So this portion and this portion cut, and this portion and this portion cut. So we get 3. So this value is 3. Now we will solve another problem, Cauchy's problem, that is del u by del x minus x into del u by del y into del x plus u equals to 0. So the problem is capital P small p plus q small q equals to r. This is the Lagrange I apply. So dx is equal to minus x dy equals to 1, dy equals to 1, and du equals to minus u minus 1. So you can write this way. From first, minus dx by x and dy by y, that you get minus log x plus y plus c. So c1 equals to x into e to the power y. From second we get dy equals to 1 equals to integration du divided by u minus 1. So we get y plus log u minus 1 equal to log c2. So c2 is equal to u minus 1 into e to the power y. Using boundary conditions, so friends, what is my boundary condition, friend? You will see my boundary condition is ux comma 0. From first equation c1 equals to t, because I putting the value x is equal to t, so c1 equals to t, and c2 is equal to sin t minus 1, sin t minus 1. So sin t equals to c2 plus 1. So this is sin c1 equals to c2 plus 1. So c1 equal, just putting the value c1, so sin x into e to the power y equals to x to the power 1, x plus e to the power 1 minus 1 equals to e to the power y into u minus 1. And now when x equals to 0 and y equals to 1, we get sin 0 minus 1 equals to e into u minus 1, and we get u equal to 1 minus 1 by e. Next problem, friends. Next problem is Euler Lagrange's formula. Find the extremal of function fx, y dash equal to minus y dash whole square plus 2xy with boundary y1 equals to 1, y0 equals to 1. So our problem is fx, y dash equals to y dash whole and 2xy, and using del f by del y dash equals to 0. So 2x minus 2y double dash equals to 0. So dash plus x equals to 0. And now we have to do in here yx is equal to minus x square by 6 plus ax plus b, and y is equal to 0, then 1. So b equals to, we get b equals to 0, y1 equals to 1. That implies a equals to a minus 1 by 6 is equal to 1. So we get A equals to 7/6. So this is my answer, A and B, putting this value. Now number 8, question number 8 is very important. It is the based on our Eisenstein property. Friends, I have already told what is Eisenstein property. Please check my video. Eisenstein property, that let fx is equal to a0 plus a1x plus a2x square plus an x to the power n zx, and there exists a prime p such that p divisible by a0 p n minus 1 such that p does not equals to a does not equals to a n, p square does not equals to a0. Then fx is irreducible over q. This is right. And fx is next option is reducible, not irreducible. So irreducible over q, this is wrong. Number C, fx is reducible for, but fx of degree 1 is reducible. Yes, obviously, because fx of degree 1 belongs to degree 1, is always reducible. In here it is irreducible, irreducible belongs to qx, so it is irreducible over q. So I hope I can clear. Number 9 is very simple, that A is equal to n cross n matrix. A is said to be diagonalizable if there exists a non-singular matrix P such that P inverse AP is equal to D, and where D is diagonalizable matrix, then which one of the following is true? A is diagonalizable. A to the power k is equal to 1. So distinct, you get distinct eigen, you can see distinct eigenvalue. So a to the power k is equal to 1, it is correct. For some k, a to the power k is equal to 0, it is not, because it is nilpotent matrix. When it is does not equals to 0, so it is not diagonalizable. And a square is diagonalizable. It may or may not be possible. Because a square is diagonalizable, we can't say. Suppose 0, 1, 0, 0. This is multiplied. I will multiply 0, 1, 0, 0. So whatever I get first 0 into 0, 0, 1 into 0. So it is 1. Sorry, it is this way multiplication. 0 into 0, 0 into 0. So we get 0. 0 into 0, 0 into 0, you get 0. And 1 into 0 and 0, 0. And 1 into 0 into 0, 0. So 0 is the diagonalizable. So A is said to be diagonalizable if non-singular matrix. Okay. And D is, which of the following statement implies A is diagonalizable? So you will see that in here A is not diagonalizable. A is not diagonalizable, but it is diagonalizable. So this portion is wrong. All the eigenvalue of A are distinct. This portion is correct. Very, very simple problem, friends. And next problem is trace of A plus trace of B. Which of the following is defined of the inner product space? So friends, this is very simple problem. The inner product property space property B equals to 0, that implies A equals to 0 and B equals to 0. So a comma b equals to 0. So friends, another factor is a comma b greater than equals to 0. So both are not 0, then it is not. First option, trace a plus trace b. Very simple. A, choose a point a comma 0 0 0. Another point b equals to a 0 minus a comma 0 comma 0. Simple. So trace a plus trace b equals to a minus a equals to 0. Both are not 0, so it is not or not inner product space. Number b, trace a into trace a comma b into trace a into trace b. So it is not possible, because you see that this total multiplications because it is the because you can see that trace a is equal to a into minus a is equal to minus a square, but which is less than 0. But we say that the inner product space is always positive, always greater than equals to 0. So this is it's not possible. Number one, date a comma b and date ab. So a equals to we take a equals to 0 comma 0 comma 1 and b equals to 1 0 0. So friends, whatever we see that date ab just multiply equals to date ab equals to 0. So friends, you see that our answer is option D. A, B, C fail the inner product conditions. Next problem is set which of the following set is countable? Set of all polynomial of real coefficient, it is not countable, because this is the theory that set of all polynomials with real coefficient, it is not countable. Set of all polynomial of rational coefficient, it is countable, it is C. And another set of this is also wrong, and this is the matrix rational eigenvalues, this is also wrong. Now I say that fx is equal to a0 plus a1x plus a2x square up to an x to the power n. Set of uncountable when a0 comma a1 up to an belongs to capital R, then mod R equals to our set of uncountable, and another is q cross q, then it is you can get 1 1 bijective mapping for rational coefficient. Set of all polynomial with real coefficient and rational roots, it is not correct, and set of rational eigenvalues, this is not correct. Now we will solve another problem. This problem is very interesting. Let A and B, A does not equals to B, are two M cross M matrix. Show that sum of each rows of A equals to 0, A is equals to 0, and sum of each columns of row A is 0. Which of the following matrix is true? So 2 cross 2 matrix, we will take 2 cross 2 matrix M, okay, and A equals to, we take 1 1 2 0. You in here you get this is the 2, this is the 2, means sum of each rows A equals to 2, and B equals to, you will take 3 minus 1 and 1 comma 1 you will get, then you will get in here 2, it is 2. So we have to take an example and counter example. Both are important for CSIR problem. So this is my example 1 2 and 1 1 0. A dot b equals to 1 1 2 0 and 3 minus 1 comma 1 1. Then whatever we get the value is 2 2 5 and 2. This is the A dot b, and I minus half of A dot b is equal to, you have to check first positions, then I dot A dot B 1 0 0 1 and half is minus 1 5 by 2 comma 1, and you will see that it is not, does not equals to 0. So first option is wrong. First option is wrong. Second option, you have to check that second option, and you have to check all the option, that B is also wrong and C is also wrong, and when you will check D, then option D is correct. How can I get? I get B transpositions. A equals to, my A equals to 1 1 0, and B transposition means row interchanging column, so 3 in here minus 1 1 and 1, this is my, and so B equals to, you will get 3 minus 1 and 1 comma 1, and multiply A dot B equals to 1 2 1 0 and 3 1 minus 1 and 1 equals to 3 plus 1 equals to 6 plus 0 minus 1 plus 1 minus 2 plus 0, so you get 4 6 0 minus 2, and I minus 1 by 4 A B T. So whatever you get I minus 1 by 4 means 1 0 0 1, and minus 1 by 4 means it will come 1 0 3 by 2 plus 1 by 2, and it will become 0 0 and minus 3 by 2 plus 1 by 2. This is the important example, so it is 0. So my last option D is correct. Thanks for watching.